Okay, so number five, again, we're going to do the same thing that I'm going to put a tick across next to each of them. I'm going to hope, because it says which statement is correct, I'm going to hope I've only got one tick at the end. So the electrons travel as photons through the metal. The word there that's making me suspicious, photons, they travel as waves through the metal. So that is incorrect. I'm going to put an X next to it. B, the electron's got a wavelength of about 10 to the minus 10. Now, I haven't got any values that I can actually calculate it, because if I had values, I'd be able to calculate and I should be a professional and pronounce it properly, de Broglie, but I mean, it's written de Broglie. I could be able to possibly calculate the de Broglie wavelength of it, but I don't have any values yet. Maybe I can make some reasonable estimations from stuff that we know, but B could possibly be true, and we can come back to it later and see why it is or isn't. The electrons are diffracted by holes in a metal. I just know that they're not. I should know that they're diffracted by the spaces between atoms. So I'm going to put a cross next to that. And it says the electrons repel each other to produce the diffraction. And again, that's if I think that I'm just misunderstanding what interference is. They behave as waves, and therefore they're going to be interfering. So that's going to be wrong. So I'm pretty certain that A, C, and D are wrong. And first I said that I was a little bit iffy about B, and I haven't got any numbers to do any calculations. But how should I know that B is going to be right? Well, there's ways I can. The first way that we said is that, um, like from reasonable estimations that we've done in the class about how much does it get accelerated through, and so on. So what's the rough speed, and then calculate the Bohr wavelength maybe. But the other thing that I know, and C kind of gave me a clue to it as well, option C, is that I know that diffraction is going to be occurring when the size of the wavelength is comparable to the size of the gap. Now, I should know, again, from the reasonable estimations that we're doing in the lessons and stuff that you expect to know, that the about 10 to the minus 10 would be the gaps between the atoms. So therefore, that's another reason why I think B is correct. So I am putting B down for that one. And yeah, I have got the mark.